Gunnar from IBM. I'm a software engineer working on the OpenBMC project. The agenda for today, an overview of OpenBMC, in case you're new to OpenBMC or need a refresher, OpenBMC today, OpenBMC releases, and finally community forum and getting involved. What is OpenBMC? OpenBMC is an open source baseboard management controller firmware stack. OpenBMC is a Linux distribution for BMCs. As of March 2018, OpenBMC is a Linux Foundation project. Many OpenPOWER systems use OpenBMC, including IBM's AC922. AC922 was the compute node in the #1 and #2 supercomputer in the world, Summit and Sierra. Inspur Power Systems, Denali System, Raptor Computer Systems, Talos, and Yadro's Nicole system are also systems that use OpenBMC. Underlying technologies in OpenBMC, we use the Yocto project for build and distribution, dbus for inter-process communication, and systemd for process management. A little history behind OpenBMC. Out of a Facebook hackathon, an open source BMC firmware stack named OpenBMC was created. This lived at github.com/Facebook/OpenBMC. In 2015, in collaboration with Rackspace, IBM also created an open source BMC firmware stack named OpenBMC. This lived at github.com/OpenBMC/OpenBMC. In 2016, 2017, as OpenBMC began to gain more traction, it was recognized by the companies working on OpenBMC that there was a need to converge. And that's exactly what happened after months of discussion in March 2018 when OpenBMC became a Linux Foundation project and a technical steering committee was formed to guide the project. The project charter is short and lightweight. It's just 5 pages. Apache 2.0 license for code contributions. We do require a contributor license agreement to be signed, either individual or corporate. And the Linux Foundation owns trademarks, websites, the GitHub organization. There's a lot of competitors in this space, a lot of competitors working on this project, and so it makes sense to have a neutral entity like the Linux Foundation. The Kernel and Yocto are already Linux Foundation projects, so it makes a lot of sense there as well. The technical steering committee is made up of 6 companies: Facebook, Google, IBM, Intel, Microsoft, and now ARM. It's chaired by Brad Bishop. And the TSC really serves to provide resolution as a last resort. The contributions to the community really drive the direction of the project. If you're contributing to the project or thinking about contributing to the project, I encourage you to get to know the TSC members. Contributors are the most important role in the project. They submit code, peer review, test, document. Maintainers steer contributors and their contributions towards project quality, standards, and best practices. Maintainers gain the role based on contribution merit and leadership, and we have roughly 30 maintainers today. Many core repositories have multiple maintainers from different companies. Some repositories have a single maintainer, while others have 2 to 3. This is OpenBMC in March of 2018, just a few weeks after becoming a Linux Foundation project. You can see the number of contributors, repositories. You can see the number of corporate contributor license agreement signers was only 3. And this is OpenBMC today. You can see the number of contributors, number of repositories has doubled. The number of CCLA signers has gone up significantly. Here's some more statistics on OpenBMC today. 500 plus people on the mailing list. There's 290 forks of OpenBMC. This was last Wednesday. There was 86 active IRC members. We're in the 26,000s for the number of Garrett commits. And this is last Friday afternoon. A lot of different commits from a lot of different people and companies. This is a screenshot of our Garrett code review. So prior to last year, we didn't have a formal release process. We had a 1.0 release, but after that, it was just periodic tagging. A release planning work group was formed, and one of their first decisions was OpenBMC would have biannual releases like Yocto, offset from Yocto by a few months. The first release following this process was 2.6 in February of this year. The next release was 2.7 in August of this year. And the next will be 2.8 in May of 2020. We're skipping a Yocto release there. Yocto has a release in November that we felt was too soon for us to have a release around. In the 2.6 release, this is February of this year, there was things for SNMP traps, IPMI 2.0, kernel and Yocto updates. In the lower left is SOL from the GUI. In the 2.7 release, this is August, the kernel was moved to 5.3. We have KVM over IP. This is using a WebSocket. It's from the GUI using HTML5 embedded directly in the web page. Also available from the GUI and the API, multiple user management, virtual media. Also in this 2.7 release was partial PLDM and MCTP. That is a messaging and transport protocols defined by the DMTF. There's also Redfish support. I have more on that later, as well as a move to Yocto 2.7. And Python is now optional, and that's the default for OpenBMC. We removed Python or made it optional for the flash reduction. I mentioned Redfish. What is Redfish? Redfish is an open industry standard for hardware management. It's defined by the Distributed Management Task Force, which is made up of about 30 paid supporters. DMTF also defines the MCTP, transport protocol I mentioned, and PLDM, the messaging protocol. Redfish started focused on servers, but it's grown. It now has schemas for BIOS and disk and memory and switches and volume, PLE device zones. And it's really meant as a replacement for IPMI over LAN. IPMI is a 20-year-old spec and has some real security concerns. Redfish is a RESTful API, uses HTTPS, uses JSON. JSON has modern language support. HTTP PS is the web protocol, and RESTful APIs are well known. And this enables your hardware management to look very similar to your other IT task. And this is a Python 3 example showing how simple it is to use Redfish. 5 lines of code using built-in Python libraries. I'm using token-based authorization here. And this is the computer systems resource in Redfish printing the system model. This isn't much different than calling a Google Maps, Twitter, or Facebook API. System management can then be performed using the same skills and tool chain as other IT tasks. And what Redfish functionality was in the 2.7 release: firmware update, inventory, logs, network, power and thermal, power state management, user management. It's kind of the base of what you would expect for hardware management using your BMC. Also things in there for memory and chassis and processors. And this is the recently merged SSL certificate panel using the certificate Redfish API. Since I'm the web interface maintainer, had to get some screenshots of it in there. The 2.8 release, this is for May of 2020. It will have things like full certificate management, LDAP. These top 2 are actually currently already merged in master. A kernel update, more MCTP, more PLDM. Move to Yocto 3.1, and Redfish schemas for event, storage, subscription, and telemetry. There'll all be some things like multiple firmware images, so we can move the web interface firmware page over to Redfish. Today, the web interface is, along with OpenBMC tools, a mix of both Redfish and our exposed internal dbus interfaces. And this is a screenshot of the new LDAP web page using the LDAP Redfish schema. So OpenBMC relies on contributions to other projects. Linux, Yocto, systemd are a couple. In general, you can expect the project to ask you to upstream your patches to these projects. This chart's a little old. We're now on kernel 5.3, but you can see as we've moved kernels, the number of patches we carry has gone down significantly. Getting involved, the first link is to the mailing list. It's a great place to stay up on OpenBMC, great place to ask questions. We also have an IRC channel. Encourage you, if you've got a quick question or two, to jump in on there. The third link is to the OpenBMC documents repository. In there you'll find documents for getting started. There's a link to our Garrett code review. Go check it out. Jump in on random reviews. And finally, our website and issue tracker. The documents repository on the left side and the mailing list archive on the right. This is a step-by-step for submitting a patch to OpenBMC. First, open a GitHub account. You need it for Garrett authorization. Clone the project from Garrett, make changes, test, commit. read the contributing document, and don't be afraid to ask for help. The community is very helpful. Jump on IRC or on the mailing list, and we can help. For submitting a patch to Linux, similar but slightly different steps. There is a kernel development guide that walks you through these. A couple of procedural things I wanted to highlight. OpenBMC is an inclusive community. There was a good piece of work done by a couple folks last year to formalize that into a code of conduct for the project. Encourage you to read that. Nothing surprising there. The security work group established a process for disclosing security issues. We have a private mailing list. The mailing list I mentioned before is public. This security mailing list is closed. Complete process for submitting a security issue is at the link below. What questions can I answer?
Are there any plans on doing a management console on top of that could manage several of these OpenBMCs?
So IBM has HMC, Hardware Management Console, and so that will work with OpenBMC-based systems.
And any open source one in plan?
Not that I know of, but since we're using the Redfish API, that's all very well documented. To write your own would be possible.
What release will support the new ASP2600 chip?
I don't know if it's going to make 2.8, probably more like 2.9.
So if it isn't 2.9 going forward, would that only work on the 2600, or would it also be, are they going to fork off at that point?
No, we will continue to support 2400, 2500. There is layers in there for each of those chips. And those layers will continue to be in there as long as someone maintains them, supports them. All right, if no more questions, I'm done. Feel free to come find me if you have anything more about OpenBMC.